If you haven't already done so, just head over to the description and get a copy of the workbook there. So all the examples that we're going to do now, you will find it in the workbook. So this is question 2, and try it on your own first and use this as your memo. Okay, let's look at A. We need to use our basic laws of exponents. So in this case, we've got some exponents on the inside of the bracket, and we've got some exponents on the an exponent on the outside. So we've got everything inside the bracket that is raised to the power of 4. Now, every exponent on the inside must be multiplied with the exponent on the outside. Remember, we're never going to multiply an exponent with a base. So you're never going to say it's -3 times 4. It's the exponent times exponent. And a common mistake that I see with this grade 9s is the sign over there. So we've got a -3 over there. So it will be a -3, and that will be to the power of 4. So I just put it in brackets. Then I know for sure that I'm getting the sign correct there. And then I've got x to the power of -8 because I multiply those two exponents, and then y to the power of 20. So that would be our first step. Now, if we carry on from there, we've got -3 to the power of 4. So it is -3 times itself 4 times. So negative times a negative is a positive, times another negative is a negative, times another negative is a positive. Our answer will be positive. Obviously, you can put that into our calculators, but 3 to the power of 4 should also be 81, and you can double check that on your calculator. And then we do not want a negative exponent as part of our answer. So how are we going to make it positive? We just move it down, and there we've got our positive exponent. And that should be it. That should be our simplified answer. So just to say that again, grade 9's the negative number in front. Just be careful. It means -3 that needs to be multiplied by itself 4 times. Don't multiply the base by the exponent. I see students do that all the time. And then don't forget to go make all the exponents positive for your final answer. Okay, next one. If we look at the second one, yeah, I also see students do all sorts with this because now we've got numbers as our base and we don't have variables anymore. So just think about your laws of exponents. When our bases are the same and we are dividing, we are going to subtract our exponents. So for our base of 2, if we subtract our exponents, it would be 2, subtract 5, top minus bottom, times for our base of 3, it will be 5 minus 2. I'm going to do this in a different way just now. So this will be 2 to the power of -3 times 3 to the power of 3. We don't want that negative exponent. We want to make that one positive. And the 3 has a negative exponent, so that stays where it is. What is 3 to the power of 3? That should be 27. And then that becomes a positive 2 to the power of 3. And so we can simplify that to 8. And that would be our final answer. How can you also do this, grade 9? So you would say, some of you would say that, okay, it would be 3 to the power of 3 at the top because the exponent at the top is the bigger one. And then for our base of 2, our exponent of 5 is the bigger one. So there would be 2 to the power of 3 at the bottom. And can you see that it's going to give us exactly the same answer? What mistakes do I see with this? Well, I've seen strange things with this. I guess since we're dealing with numbers, what I have seen is that students divide 2 divided by 2 is 1 or something like that. And then I'm not even sure what to do with the exponents, but we can't do that because it's not a normal 2. It is a 2 to the power of 2. So it actually is 4. And 2 to the power of 5, we can't just divide it by 2 because it's not a normal 2. The moment that you see exponents, we need to think about laws of exponents and we stick to those. Okay, so there we've got our final answer. Let's look at C. Okay, again, we are dividing pretty straightforward. We just have to identify our bases that are the same. There's one term at the top and bottom. So when our bases are the same, we can just subtract our exponents. So again, we're going to do this in two different ways. For my base of m, exponent at the top minus the exponent at the bottom. For my base of n, my exponent at the top minus my exponent at the bottom. And that would give us m to the power of negative 2 times n to the power of 3. We do not want that negative exponent as part of our final answer. N has got a positive exponent, so we leave it where it is, and that one becomes over m to the power of 2, and that would be our final answer. I like this method because when we're dealing with negative exponents from the beginning, I find that this just leads to the least common errors, what I see students make. Okay, so or what you could have done is that if you look at your base of m, you can see that at the bottom is a larger exponent of 5. So that means that our m's would then be at the bottom. You could look at it like that, and I know some of you look at it like that. And with our n, our biggest exponent is at the top, so there would be 3 left there. Gets us to exactly the same answer. How does that work again? So we've got at the top, we've got m times itself 3 times. And at the bottom, we've got m times itself 5 times. So that m divided by that m just gives you 1, 1, 1, and there's 2 m's left at the bottom. And obviously we can follow that same logic with our basis of m. So however you do it, just needs to make sense to you. Let's just simplify the first bracket first, because that one is to the power of 3. So we need to just simplify that first bracket. And that would be x to the power of 9, not 6. We're not adding them, we are multiplying, and y to the power of 6. And then we are multiplying it by this one over here. I can just remove the brackets. It doesn't serve a purpose. Otherwise, over there, just showing us that these two are being multiplied. That's what the brackets mean, right? So since it's not raised to a power over there, I can just remove the brackets. We just need to multiply those. Okay, so now we look for our similar bases. We are multiplying. The law of exponents says that if we are multiplying, everything is being multiplied there, and our bases are the same, we're going to add our exponents. So we are adding that, and we are adding that. Note what happens over there. So that would be x to the power of 6, y to the power of 11, and that would be simplified. Final answer. So sometimes it helps when we kind of break this up to clearly see what's going on, especially if you're only starting to do this now. So that first bracket is being multiplied by itself, and then it is being multiplied by that second bracket. But all of that is just being multiplied. So we can say x to the power of 3 times y squared times x to the power of 3 times y squared times x to the power of 3 times y squared times that. Everything is just being multiplied. And we can put the bases that are the same together. All right, let's look at the next one. Okay, well, we can see that we are multiplying and our bases are the same. What is a little bit different over here is that we've got an x that's part of the exponent. But don't let that confuse you. Let's stick to our laws of exponents. When our bases are the same, in this case a, our base stays the same, and we add our exponents because we are multiplying. So let's do that. X plus 3 plus 2 minus x. We are adding the exponents. There they are. There's the first exponent that we are adding, and there's the second exponent. So we just have to simplify that. So that would be x plus 3 plus 2 minus x. Put those like terms together. The x minus x, they will cancel out, and then 3 plus 2, which is 5. And that's it. I'm trying to think of common errors that students will make with this. I think they just feel a little bit confused because the x is part of the exponent, but we just stick to our basic laws. Okay, next up, we've got some exponents that are fractions. Okay, let's see what we can do with that. Let's just do what we normally would with our laws of exponents. So when it's in a fraction like this, the exponent on the outside needs to be multiplied with the exponent on the inside. So there we're going to land up with a to the power of a half over c to the power of a half times same thing over here. There we're going to land up with c to the power of a half over a to the power of a half. And note there, since these are fractions that's being multiplied, we can just cancel those out because they're exactly the same. A to the power of a half, c to the power of a half, and we would land up with 1. Okay, last question for question 2. So let's just do this step by step. If we have a look at the denominator, that is in its simplest form. So for now, we just leave that. If we look at the first set of brackets, that's not raised to a power, so we kind of leave that for now. Where we'll have to start is over here, where we've got that bracket that is to the power of 3. Now, exponents on the inside gets multiplied with exponents on the outside, never exponents and bases. So let's go ahead and do that. So that would be multiplied by the negative 3. Because that's a negative number, I'm going to keep it in that bracket. And then it will be m to the power of 15, and it will be n to the power of 3. Okay, that's our first step. And I am going to just work out on the side over here what negative 3 to the power of 3 is. Negative 3 times negative 3 will give us a positive 9. And if we take the 9 and we times that by another negative 3, that will give us negative 27. All right, so over there, just writing that one over. If I say 6 times negative 27, well, 27 times 6, there's different ways that we could obviously work that out. What I'm going to do is I'm going to say 20 times 6 plus 7 times 6. There's obviously different ways that you can break that up. What is 20 times 6? That should be 120. What is 7 times 6? That should be 42. So that should be 162. And it will be a negative. Negative times a positive. So over here we'll have negative 162. Let's put those bases. Let's simplify that because everything is being multiplied. So for our base of n, or let's start with m, 4 plus 15, which would be 19, and then n would be 5 plus 3, which is 8. Okay, so we've simplified the numerator. Now let's simplify everything else. So now we are dividing. The law of exponents says that if we are dividing and our bases are the same, we're going to subtract the exponents. Okay, so however you decide to do this, I am going to say my m, it will be 19 subtract 6. That will be m to the power of 13. And then it will be n to the power of negative 1 because it will be 8 minus 9, which will be minus 1. And then negative divided by a positive will give us a negative number. And we need to simplify that. So we need to simplify 162 divided by 12. Obviously, you can use your calculator. I'm just going to do it slowly without my calculator because I don't know where it is. So if I have a look and see 2 can go in there, then we have 6, and that divided by 2, what is that? 81. Yes. Can we divide that further? Can we divide that by 2 again? No, because that's not divisible by 2. Can we divide that by 3? I'm sure we can. So 3 goes in there twice, and 3 goes in there 27 times. Is that true? Yeah. So that must be its simplest form. So that simplifies to 27 over 2. We're almost done. There's just one more thing that we need to do. We just need to make sure that that exponent is positive. And how are we going to make that happen? That one stays where it is. It's got a positive exponent. So to make that exponent positive, we just move it down and write it in the denominator. And we don't have to write that one even. And there is our final answer. So it's just step by step showing all your working. If you do it slightly different, that's perfectly fine. Your working out doesn't have to look exactly like mine, but make sure that you don't try and go straight to the answer. Show your working out. Okay, I hope that went well. Head over to question 3.